All right, so we're looking at the third free response question for Unit 5. This one originally was written to be no calculator. Obviously, we can check some things if we needed to using the calculator, but remember that you have to show all the work like you don't have a calculator. Okay, so we have two different functions we're talking about here. We have g, which is a continuous function. G is twice differentiable everywhere except when x is 0. All right, and then we have f, which we know f of 0 is -1, and we know the derivative of f. So the question for A is to find each critical point of f first, and then classify those critical points and justify your answers. So let's just start with the critical points. So the critical points are found when the first derivative is equal to 0. So we would just take that first derivative and set it equal to 0. And e to the x is never going to be 0, so we're not going to use that one. But x squared minus 5/4 is definitely going to be 0 2 times. That is when x is the positive and negative square root of 5, and then over, and I just went ahead and took the square root of 4 and got 2. So those are your critical numbers. I'm going to have to squeeze it in here because the problem takes up so much space. Okay, so then to classify them, we are going to use a number line and a sign chart. So we'll have the negative square root of 5/2 and the square root of 5/2. And do we have an interval? We do not. Okay, so then I'm going to test points on each side and plug them into the first derivative. So I'm going to find f prime of -3, f prime of 0, and f prime of 3. And we get positive, negative, positive. Okay, so if we're looking at f or x equals negative 5, the square root of 5/2, because the first derivative changes from positive to negative, that is going to create a relative maximum. And then we do need to tell why. So because f prime of x changes from positive to negative there. Okay, and if we look at the other point, positive square root of 5/2, f prime changes from negative to positive there, which is going to create a relative minimum. Okay, so let's move on to the next one. B is still talking about f, so we don't need the graph of g. We want to know what values of x does f have a point of inflection. All right, so to find the point of inflection, we do need to find the second derivative. And on this particular problem, to find the second derivative, we're going to have to do the product rule, where I'll leave the first part of it alone and multiply by the derivative of the second, which the derivative of e to the x is e to the x. Then I'll leave the second one alone and multiply by the derivative of the first. Okay. Now, if you are just asked to find the second derivative, you can stop right there. But because we need to find when this is equal to 0, I'm going to do a little bit more work with it. So I'm going to factor out e to the x. And when you factor it out of the first, what's in front of the plus sign, it leaves you with x squared minus 5/4. When I factor out of the second one, it leaves you with 2x. Alright, so we're going to need to find when this equals 0. So I'm going to go ahead and write it in descending order. Alright, e to the x is never going to be 0, so we would take this quadratic equation and set it equal to 0. Now, I'm not a huge fan of factoring equations whenever you have fractions, so I'm going to multiply by 4. Then, because of the Pricer rule of 4, I know to get 4x squared, I'm going to do 2x and x, because this 8 is even, right? And then to get 5 and 1, for sure, it's 5 and 1. And then I would want to have the positive 5 and the negative 1. So that's going to give us two values where the second derivative is 0. Alright, so what I would do is I would take those two, put them on my number line. Alright, and then I'm going to test a point in each region, and I'm plugging it into the second derivative. So when I plug in negative 3 into the second derivative, just go ahead and use your calculator. You are going to get a positive. When we plug in 0, we're going to get a negative, and when we plug in 1 into the second derivative, we're going to get a positive. Let me look back at the question. Okay, we're trying to figure out points of inflection. So these are each going to be points of inflection because the second derivative is changing signs. So because f double prime of x changes sign at x equals negative 5/2 and x equals 1/2, the graph of f has points of inflection there. Okay, C is all about G. And I love these questions. I hope I put one on there for you guys. But we're looking at the graph of G. And we're determining if G prime and G double prime are positive or negative. Alright, so when I look at the interval between negative 3 and 0, let's just talk about G prime. We're looking at this interval right here. And because the function is increasing there, then that means that G prime is positive. Alright. Then for the second interval for the first derivative from 0 to 3, when I look at that section, the function is also increasing, which means that the first derivative is positive. Okay, the second derivative, if you're looking at the graph of the original function, is all about concavity. So in that green interval, the function is concave up. And when the function is concave up, the second derivative is positive. All right, and then for the yellow section of the graph, the function is concave down, which means that the second derivative of the function is negative. Okay, we're not done. We have to give a reason. So I said all the reasons. Let's just go ahead and jot down all the reasons. So g prime of x is positive on the intervals from -3 to 0 and 0 to 3 because the graph of g is increasing there. Right? Then we would say g double prime is positive on -3 to 0 because g double prime is concave up there. And then finally, g double prime is negative on the interval from 0 to 3 because g double prime of x is concave down there. Okay, and then the last question we have, we're going to find if h is increasing or decreasing, and h is the product of f and g. So to determine if h is increasing or decreasing, we have to find h prime. And we're going to do the product rule, and this is basically the product rule definition. Right, and typically you get points for just writing that, and then you'll get points for finding what this is at 0. Now in these problems you may or may not be able to find exactly what the value is. I think we can on this one, but sometimes you really just find if the first derivative is positive or negative at 0, and that's all we really need to know. But f of 0 is given to us right here. So f of 0 is -1. G prime of 0 is given to us right here. This 2. We could estimate it from the graph, but we don't have to. It's going to be 2. G of 0 we can get from the graph. G of 0 is 2, or we can get from the table right here. And then f prime of 0 we can get from the function. So we would put 0 in for both of these x's, and then that is going to give us -5/4. Alright, and then because you guys get to use a calculator, we can just put that in the calculator, or we could add or subtract it on our own. Either way, we're going to get -9/2. So because h prime of 0 is less than 0, or you can say because h prime of 0 is negative, whichever way you want to word it, h is decreasing at x equals 0.